Unit 4 is based on rational expressions. So before we go further, I want to talk about what is a rational expression. A rational expression is an algebraic expression whose numerator and denominator are polynomials. So let's look at this right here. This is a rational expression. The numerator is a polynomial. The denominator is a polynomial. Like a numerical fraction, a rational expression is undefined when the denominator is 0. The value or values that make a rational expression undefined are called an excluded value. So remember, that's when the denominator equals 0. Remember that to simplify fractions, you can divide out common factors. And when it's a factor means things are being multiplied together. And if they appear in both the numerator and denominator, we can divide them out. So let's look at number 1. In order to figure out common factors, we are going to have to factor. So let's factor the top. The top has a GCF of 8. And the bottom is r minus 9. Notice I have r minus 9 over r minus 9. We can divide those out, so we get 8. And I also want to note what is our excluded value. So the excluded value is when denominator is 0. What's going to make this denominator 0? R cannot equal 9. So we're going to box that also. Let's look at number 2. Number 2, I can't factor the numerator. I can factor the denominator. X plus 2, x plus 3. 2 and 3 multiply to 6. 2x, 3x, that gives me 5x. I have an x plus 2 that divides out on the top and the bottom. So I get what's left over on the top? Nothing. So we have a 1 left over. And then I have x plus 3. Let's look back. What would have made our denominator 0? Negative 2 and negative 3. So x cannot equal negative 2, negative 3. And if you had trouble seeing that, you can say x plus 2 equals 0, x equals negative 2, x plus 3 equals 0, x equals negative 3. That's how you can find that negative 2, negative 3. Go ahead and try number 3. Make sure you note to yourself what are the excluded values. Factoring the top, let's see, k plus 8, k minus 5, 8k minus 5k is 3k, k plus 8. We can divide out the k plus 8, and I'm left with k minus 5. What would have made my denominator equal to 0? K equals negative 8, so k cannot equal negative 8. That is my excluded value. If we look at number 4, we see that we have a monomial and a monomial. So what that means is over here, we had two things we're adding and subtracting, so that's a binomial. When I have monomials, I'm thinking of it as 3 times I have an x squared x times x. Those are my factors. And then 9 times x. So here, 3 goes into 9 3 times. I can divide out an x. On the top, I'm left with an x over 3. Let's look back. What would have made this denominator equal to 0? 0. So x cannot equal 0. Okay, so here's an important note. X minus 2 and 2 minus x are opposites. To simplify, so I can make 2 minus x look like x minus 2. But here's how. I'm going to factor a negative 1 from this to get that, which I can write as this. So this is what we want because then I have an x minus 2 and an x minus 2. So let's see how this works. On number 5, let's look at the numerator. I have a GCF of 3. Let's look at the bottom. I need to get a 6D squared, so I'll try 2D and 3D. I need to get a 1 on the end. I want a positive D in the middle, so the middle gives me 3D and 2D, so I'm going to want a negative and a positive. Let's check this. 3D times 2D is 6D squared. I have a positive 3D, negative 2D, so I get a positive D. 1 times negative 1, negative 1. I notice that this 1 minus 3D and 3D minus 1 are very similar. So what I can do is I can change the signs. My goal is to make this 3D positive. I want this 3D to be positive. This one is negative. I want this one to be negative. So I'm going to factor out a negative 1, and that changes the signs. I now have a positive 3D and a negative 1. So those can cross out. I'm now left with negative 3 on the top and 2D plus 1 on the bottom. Let's check for our excluded values. Here, again, you can think of it as 2D plus 1 can equal 0, 3D minus 1 can equal 0, minus 1 divide by 2, negative 1/2, add 1, divide by 3, positive 1/3. So D cannot equal, or I should put not equals there. D cannot equal negative 1/2 and 1/3. Go ahead and try number 6. You do have to factor both the top and the bottom on this one. For the top, you should have got a minus 6, a plus 2. On the bottom, a plus 7, a minus 6. On both top and bottom, I can divide out an a minus 6, so I'm left with a plus 2, a plus 7. This tells me a cannot equal negative 7. Here, a cannot equal 6. -7 would make this piece 0. 6 would make that piece 0. Go ahead and try number 7. You'll need to factor the top and the bottom. Maybe pause the video so that they have some time to factor the top and the bottom. Now that you factored the top and the bottom, let's go ahead and see what you got was correct. Let's see. 2x and x. For 12, I'm going to try 3 and 4. I can't put 4 there because that would give this one a GCF. So I'm going to try 3 and 4. That gives me an 8x and a 3x. If I make that negative and that positive, we should be good. For the bottom, 2x and x. I'm going to try 4 and 1. If I put a 4 here, that gives us a GCF, and we didn't have a GCF. I'm going to do 1 and 4. X, 8x. If I make both of them negative, I get a negative 9x. I can divide out the x minus 4, so I get 2x plus 3 over 2x minus 1. And here, x cannot equal 1/2. Here, x cannot equal 4. Number 8. Looking at the top, we have to factor it. There's no GCF, but I notice there's a y cubed. 27 is a perfect cube. 125 is a perfect cube. So this is our cubes, sum of cubes. So here, a equals 3y. Cube root of 27 is 3. Cube root of y to the third is y. And b equals 5. Cube root of 125 is 5. When I'm writing out, we have AB, A squared, AB, B squared. So let's see. 3y, 5, A squared. 3y times 3y is 9y squared. When I multiply these, I get 15y. 5 squared is 25. And then for our signs, we use SOAP. Same, plus, opposite, minus, always positive. On the bottom, we have a GCF of 5. I can divide out the 3y plus 5, and I'm left with 9y squared minus 15y plus 25 all over 5. And what will make this 0? So 3y plus 5 cannot equal 0. Y equals minus 5 over 3. Number 9. Number 9, they're telling us f and g. Here, it says we're going to do g divided by f. So, g goes on top, f goes on bottom. Now we need to simplify. The top is the difference of squares. We can divide out the n minus 2. So I get n plus 2. And our excluded value, n cannot equal 2. 2 would make that denominator 0. Let's set up 10. I'm going to do g divided by f squared. So what's g? N squared minus 4. F is n minus 2 squared. Factor the top. And then on the bottom, since I have n minus 2 squared, I have n minus 2 times n minus 2. So that divides out, and I'm left with n plus 2 over n minus 2. From the bottom, here n cannot equal 2, here n cannot equal 2, so I just have to write it once. Number 11. 11 is going to be the last one we do. We're not going to do 12. All right, for 11, we have to use our exponent rules. We have just a bunch of monomials. Here, I have xy to the third, so we have to distribute. So I'm left with x to the third, y to the third. Xz to the fourth, so distribute. X to the fourth, z to the fourth. Here I have y to the fourth. I'm going to also distribute x squared squared. That's x to the fourth. Then I have y squared. Distribute that 2. That's z to the fourth, x to the fourth. Now let's combine everything. On the top, x to the third, x to the fourth, that's x to the seventh. Y to the third, y to the fourth, that's y to the seventh. Z to the fourth. All over, here I have x to the fourth, that's x to the eighth, y squared, z to the fourth. Now using our exponent rules, we can subtract here. So I have 7 on top, 8 on bottom. 7 minus 8, that's 1 on the bottom. Y to the 7th over y squared, that's going to give me a y to the 5th on top. And then my z's cross out. So that is my answer there. Number 11 really just uses our exponent rules. So when we have a power to a power, we multiply. Here we add 3 plus 4 is 7, and then we subtract.